All right, ladies and gentlemen, what I'm going to be doing right now is I'm going to be going through day number 1 assignment. And just as a reminder for you all, the assignments that we do for each day, the actual assignments, so you'll see right here, it just says assignment. Those are not actually going to be turned in any way, shape, or form. And that's just for simplicity's sake on my end. So what you will be turning in every day is going to be your exit tickets. Those are actually going to be graded. So please make sure you're doing your exit tickets every single day. But the actual assignments themselves are just to kind of help you understand the content. But let's take a look at this first one here. Electrostatics question number 1. So it says, so a balloon has been rubbed on pseudonym's head and then hung from the ceiling. A negatively charged rod is brought close to the balloon, and the rod repels the balloon. Well, what charge does a balloon have? Well, if we know that it is repelling the balloon, and we are using a negatively charged rod, what we know is that, so if I have a negatively charged rod, and it repels it, so these are going to be going away from each other, then this also must be a negatively charged balloon. This method of charging is called induction. And then how do you know this? Is because there's no contact being made, and those negative charges on the rod and the negative charges on the balloon are it's pushing away, since we know it, we said it's repelling it, so therefore we know that the balloon has a negative charge. What was the type of charge on Sue's hair immediately after the balloon was rubbed on it? And that is going to be a positive charge. So right after Sue rubbed the balloon on her hair, she ended up getting a positive charge on her hair. And her hair gained this charge through friction. So what's happening there is all the electrons from her hair are jumping onto the balloon. So since she has a lack of electrons in her hair, she has a net positive charge in her hair, and the balloon has an excess of electrons, so the balloon has a net negative charge. Okay, so going on to the next one. Number 2, a negatively charged rod is brought close to a neutral electroscope, and the electroscope is attached to the rod, touches the rod, and then is repelled by the rod. What was the electroscope, or why was the electroscope attracted to the rod? What charge does the electroscope have before it touches the rod and after it touches the rod? So let's look at that first question there. Why was the electroscope attracted to the rod? All right, well, it was attracted to the rod because at the time, this, was neutral. Did I just spell neutral wrong? My apologies. Look at me. At the time, the electroscope was neutral, and if this is a negatively charged rod, any charged object is going to attract neutral objects, right? Because neutral objects have both protons and electrons, so it's attracting those positive protons that are within the neutral electroscope. So what charge does the electroscope have before it touches the rod? Well, like we said, it would be neutral. And then after it touches the rod, well, now what has happened is some of those electrons have jumped to the electroscope. So now we have a negative charge on the electroscope, and we also have a negative charge on the rod. Okay, let's look at the third and final question. A piece of styrofoam is rubbed with rabbit fur. The styrofoam is then lifted and brought close to a leaf electroscope. The electroscope leaves spread apart. What does this prove about the styrofoam? What charge does it have? Okay, so we are charging the styrofoam via friction. So this would be taking the rabbit fur over here and the rod itself, and we are charging via friction. All right, well, the rabbit fur, just like when we talked about the hair in the balloon, the rabbit fur is going to be like the hair, and it's going to end up with a positive charge because it's taking or it's giving all of its electrons to this rod, right? So this rod ends up becoming negatively charged. Um, and we know that because of what happens when we're charging something. It is a transfer of electrons. Protons can't move from place to place. It is a charge is a flow of electrons. So what's happening is when we take that negatively charged rod, all those electrons are flowing down into the electroscope. So we have negative charges within the ends of these, within the leaves of these electroscopes, and that is causing them to repel one another, because what we know about charges is we have like charges, those are going to repel each other. If you have any questions, let me know via email.